In this video, we'll be solving higher degreed equations using the technique of factoring. We'll start by setting the equation equal to 0. We'll factor using a known factoring technique, and then we will apply the zero product property. Now, this is the same procedure when we were solving basic quadratics by factoring. What's going to be different here is when you apply the zero product property. In many examples, you'll be left with quadratic equations that you need to use quadratic formula or square root property to solve. So let's solve x to the third minus x squared minus 5x equals negative 5. The first thing we want to do is set this equal to 0. So I'll add 5 to both sides. X to the third minus x squared minus 5x plus 5 equals 0. Now we want to factor using a known factoring technique. This polynomial has 4 terms to it. The technique we want to apply is factor by grouping. We'll factor out a GCF of x squared out of our first 2 terms, leaving us with x minus 1. We have a GCF of negative 5 in our second 2 terms, leaving us with x minus 1. We factor out the common binomial factor, x minus 1, and we're left with x squared minus 5. And we're still equal to 0. After factoring, we see that we have a quadratic factor, and we try to factor it further, but this is not the difference of 2 squares or the difference of 2 cubes, so I cannot factor it any further. At this point, we'll apply the zero product property. X minus 1 equals 0, and x squared minus 5 equals 0. Our first equation is linear. We solve it by adding 1 to both sides. We get x equal to 1. Our second equation is quadratic. We already tried factoring it, and it didn't factor, so now we move on to a different technique for solving quadratic equations. Since there's only a quadratic term and a constant, square root property is the most direct technique. However, if you want to use one of the others, feel free to do that. For square root property, we need to isolate the squared term, so let's add 5 to both sides. And now we take the square root of both sides. We get x equals plus or minus the square root of 5. We look to see if we can simplify our square root. We cannot. The solutions to this equation is x equals 1, x equals positive square root of 5, and x equals negative square root of 5. Next, let's solve y to the fourth minus 216y equals 0 by factoring. Our equation is already set equal to 0, so we start factoring. Notice that we have a GCF of y we can factor out, leaving us with y to the third minus 216. We recognize 216 to be a perfect cube. We have the difference of 2 cubes here. This is y to the third minus 6 to the third. And we'll be plugging this into our difference of 2 cube formulas, which is a minus b times a squared plus ab plus b squared. Don't forget your original GCF of y out in front. And then we have y minus 6 times y squared plus y times 6 plus 6 squared equal to 0. I want to clean up that last factor. Y times y minus 6 times y squared plus 6y plus 36 equals 0. We're left with a quadratic factor. We always want to try to factor it further. This one, however, will not factor. We can't come up with 2 numbers that multiply together to be positive 36, but add together to be positive 6. So at this point, we'll apply the zero product property and set each one of these factors equal to 0. Our first equation, y equals 0. Y is already solved. That's our first solution. Our next equation is linear, so we'll just add 6 to both sides. Our second solution is y equals 6. Our third equation is quadratic. Well, we already tried factoring it, and that didn't work. So now we need to move on to one of our other techniques. This equation does have a linear term, so that eliminates the technique of square root property. My next choice would be quadratic formula. We get y equals -6 plus or minus the square root of 6 squared minus 4 times 1 times 36 all over 2 times 1. We want to start cleaning up and simplifying our radical. -6 plus or minus the square root of 36 minus 144 all over 2. It's going to be -6 plus or minus the square root of -108 all over 2. Now the square root of -108, we can take an I out there. Also, the largest perfect square that's a factor is 36. That goes in 3 times. So this becomes 6i square root of 3. -6 plus or minus 6i square root of 3 all over 2. And now we want to simplify the fraction overall. So let's split it into 2. -6 over 2 plus or minus 6i square root of 3 over 2. And then we can simplify the 6 and 2's in both fractions. We end up with y equals -3 plus or minus 3i square root of 3. That is our third and fourth solution.